Hey everybody, it's Mrs. Harbin. We're at 6.2, mole conversions. Alright? It's going to be a mole revolution for you. You're going to be able to use all this mole stuff that we know to calculate some conversions. So let's get busy. Make sure to read chapters 10, section 1 and 2. And look, a couple of bonus problems for you. Alright, please do that. Alright, things we're going to learn today to convert. Convert between mass and particles, convert between volume and mass, convert between volume and particles, and then convert from moles to something else or from something else to moles. Okay, so what are we going to do? Well, here's what you got to use. You got to use 1 mole equals 6.02 times 10 to the 23rd, and that's either atoms, molecules, all right, and we could use MC for molecules or formula units. Formula units. Okay, and we can use 4U's for formula units. All right, 1 mole also equals 22.4 liters of gas at STP. All right, it's not true unless it's a gas at STP. And 1 mole equals the mass in grams from the periodic table. Okay, so you have to review this, you have to know this, and don't you forget it. It says little mole, look, he was digging, he's got all kinds of dirt in his nails. Okay, so what are the smallest pieces of matter? Most elements are made of atoms. Okay, but there's 7 elements, so most elements are made of atoms, and that's most of them. There's 7 elements that are made of molecules. Do you know which 7? The super 7, the diatomic elements, are made of molecules. So atoms represent most elements. Molecules represent 7 elements, so these are called representative particles. Ionic compounds are metals and nonmetals, or compounds with polyatomic ions in them. They're made out of, this part of it is called a formula unit. Formula unit. And finally, molecular compounds are made, they're 2 nonmetals, are made of molecules. Like this would represent a molecular compound. Molecular or covalent, another word for molecular is covalent. All right, so these are the representative particles, the things that represent the smallest pieces that represent different kinds of matter. So we have to be able to convert between mass and particles. So how many formula units, so this is what we're trying to find, are in 108.63 grams of NaCl? This is what we're given. So we're given the grams of NaCl. Let's start with that, 108.63. Oh, that's 3 grams NaCl. We have to find formula units. So I need to do a 2-step problem. Why? Because of what I memorized, I need to use this one because that's particles. And I need to use this one because that's grams. So let's go do it. Cancel out grams of sodium chloride to change it into moles of sodium chloride. Cancel out moles of sodium chloride to change it into formula units. 4U's of sodium chloride. Oh, that's so nice, Mrs. Harbin. Okay, so what do I put here? Well, according to our information about 1 mole equals 1 mole equals 1 mole equals, all right, you have those memorized. 1 mole equals the mass in grams from the periodic table. So I have to go get grams for Na and Cl, and that's 22.99 and 35.45. Did I memorize that? Well, kind of. And then I add those together, and I get 58.44. And then, according to my 1 mole equals stuff, I know that 1 mole, the number 1 always goes with moles, equals Avogadro's number of formula units. So then math-wise, look, grams cancel grams of NaCl, moles cancel moles of NaCl. I'm left with formula units, 4U's of NaCl. Should we have a lot or a little? Well, we should have a lot, because there's this many in 1 mole, and there's a lot of grams here. So I do 108.63 divided by 58.44 times 6.02E23, and I get 1.12 times 10 to the, always go 2 decimal places, 10 to the 24th formula units of NaCl. That's a lot of tiny pieces, which makes sense. This is 1 mole. This is over 1 mole, because you know the 58 is 1 mole, and this is more than 1 mole. So this should be more than 1 mole of formula units. How about converting between particles and mass? Well, you already know what 1 mole equals 3 different ways. You should have that memorized. You should be able to fill this in. Okay, given atoms of iron, 5.65 times 10 to the 18th, and that's atoms of iron. We'll use the periodic table and find Fe, right? Are found in your drinking water. How many grams of iron? Find grams, all right? So 1 mole equals liters. atoms, molecules, 4 millunits, or grams. So I have to use this one because it has atoms and moles in it. And then I have to find grams, so I have to use this one because it has moles and grams in it. So this is a two-stepper. Boomch, boomch. Atoms of iron can change into moles of iron using this conversion factor. Woohoo! And then moles of iron can change into grams of iron using this conversion factor. But there's no number here. That's okay. There's a number here that you memorize. 1 mole has Avogadro 6.02 times 10 to the 23rd atoms of iron. And then number 1 goes with moles. And where do we go get grams? Periodic table. Periodic table. 55.85 grams of iron. You don't have to add anything together because it's just iron all day, iron Fe. Atoms cancel atoms, moles of iron cancel moles of iron. And then 5.65 times 10 to the negative 18th divided by 6.02 times 10 to the 23rd times 55.85 gives you 5.24 times 10 to the negative 4th grams of iron. Okay, so why is this such a small mass? This is 0.000524. Why is it such a small mass? Well, look, there's Avogadro's number, so there's 5 powers of 10 difference between this and this. And this is less, so this should be a lot less than 1 mole. Okay, can we convert between mass and volume? Only if you memorize this stuff. 1 mole equals boom, boom, boom. You fill in those, right? So you're given 78 grams of carbon monoxide. Uh-oh, that's bad news. You need to find liters of carbon monoxide. So you have 78.4 grams of CO. Right? Now, according to these, atoms, molecules, 4 millunits. According to these, if I'm given grams, then I have to use this conversion factor because it's the one with grams. I'm trying to find liters, I have to use this conversion factor because it's the one with liters. So let me cancel out grams, change it to moles, carbon monoxide, and then cancel out moles and change it to liters, carbon monoxide, all right, assuming it was at STP. So what numbers do we fill in here? Well, 1 goes with moles, right here. Then the grams, we got to go get it from the periodic table. So I have to add 12.01 plus 16.00, and I get 28.01 grams, periodic table. All right, moles and liters. Moles are number 1. Where do I get liters from? It's a number you memorize, 22.4 liters. If it's a gas, it is a gas. Gas, carbon monoxide is a gas, STP, so we can use it. And then math-wise, cancel out grams of carbon monoxide, moles of carbon dioxide. We're left with liters of carbon. I said dioxide, I meant monoxide. That's the toxic one. And then I do 78.4 divided by 28.1 times 22.4, and I get 62.70 liters of carbon monoxide. Okay. All right. Should we do another one? Yes, Mrs. Harbin, please. Okay. Convert between volume and mass. All right. Please make sure you know what 1 mole equals, 1 mole equals, 1 mole equals. All right. If you don't have these 3 things memorized, do it now. Okay. In this problem, we're given 38.6 liters of NO2. Try to find grams. All right. So it doesn't matter how I do these, which one goes first, which one goes second. I have to know them all. If my given has liters, then I know I have to use the mole conversion with liters in it. If my find has grams, I know I got to use the mole. So this is a 2-step problem because the units are in 2 different of the equalities. Okay. So there's liters of nitrogen dioxide. Have to change it to moles of nitrogen dioxide. And then moles of nitrogen dioxide can change into grams of nitrogen dioxide. Well, let's put in some numbers. Moles are number 1 when you do with liters, and there's 22.4 liters for every 1 mole. Okay, we could assume it's a gas at STP. 1 goes with moles, 1 goes with moles, and then grams, we got to go get grams from the periodic table. When I go get the grams, I have to add up nitrogen plus 2 oxygen, 14.01, 16.00 times 2, and I get 46.01 grams. I go get that from the periodic table. Liters of nitrogen dioxide cancel. Moles of nitrogen dioxide cancel. We're left with grams of NO2. All right, math-wise, 38.6 divided by calculator. So do this, 38.6 divided by 22.4 times 46.01. That's how I plugged it in my calculator. And doing that, I get 109. Nope, I don't get that. I get 79.29 grams of nitrogen dioxide. Okay. Any more? You betcha there's more. Remember this. 1 mole equals 1 mole equals 1 mole equals. Okay. Liters, grams, atoms, molecules, formula units. All right, this is 22.4. This is PT, and this is Avogadro's number. All right. So what's going on here? Well, we're given 3.22 times 10 to the 24th molecules of carbon dioxide. We have to find liters. How many liters? Find. So we need to use this one because it has liters. And then we also need to use this one because it has molecules. So it's a two-step boomch, boomch. Molecules of carbon dioxide can change into moles of carbon dioxide using this conversion factor. And then moles of carbon dioxide can change into liters of carbon dioxide using this conversion factor. Moles are number 1. How many molecules in a mole? Avogadro's number of molecules in a mole. 6.02 times 10 to the 23rd. Hey, moles are number 1. Why? Because the number 1 goes with moles, the unit of moles. What number goes with liters? 22.4. Math-wise, 322 times 10 to the negative 24 divided by 6.02 times 10 to the 23rd. Bye-bye molecules of carbon dioxide. See you later, moles of carbon dioxide times 22.4, and you get 119.81 liters of carbon dioxide. Okay? Check my math, peeps. Okay, so this is what you do if your units aren't moles. This is not moles, and that's not moles. So I have to use 2 mole conversions. But what if one of your units are moles? How many moles? Find moles. Given grams. Given grams. Well, hey, look, there's little moles there. 84.6 grams of Ki times, remember 1 mole equals, 1 mole equals, 1 mole equals. All right. We are given grams, liters, and then atoms, molecules, formula units. All right, and this one we're given grams, finding moles, so we only have to use 1 because both of the units in our problem are the 2 we're concerned about, grams and moles. This is 1 step because we only need to use 1 conversion. 1 mole equals, where do I go get grams? Periodic table. Ki is end up being 166.00. Grams cancel grams, and we're left with moles of Ki. And then 84.6 divided by 166 gives us 0.51 moles of Ki. All right. Is there more? Yes, there's always more. More things to review. So we have a mole revolution going on. All right. Make sure you memorize. 1 mole equals, 1 mole equals, 1 mole equals. Okay. You can convert between mass and particles, volume and mass, volume and particles, moles to mass, all right, or particles or volumes. You can do it all if you remember this. Most elements are made of atoms. 7 elements are made of molecules. Those are the diatomics. Ionic compounds are made of formula units. All right. Go beetles. Molecular or covalent compounds are made of molecules. So those are the tiny particles we talk about. What else do you have to remember? 1 mole equals Avogadro's number of atoms, molecules, formula units. 1 mole equals 22.4 liters of gas at S. It's going to be all right because we're going to keep calm and calculate moles. 1 mole equals mass in grams from the periodic table. All right. Don't forget this stuff, people. All right. So do a little bonus and keep on the lookout for suspicious looking moles. Peace out, friends. All right. Can you do it? Yes, we can.